Alright, for this video we are going to talk about the speech motor system, which at the top you have the cortical speech planning and programming, which leads directly to the direct activation pathway and the indirect activation pathway, as well as the control circuits down to the sensory system. And then you have the final common pathway, which goes from that to speech to the sensory systems, which goes to the indirect activation pathway. And then both the direct activation pathways also lead to the final common pathways. There are many motor disorders that are associated with the motor speech system, and the first one I'm going to start with is flaccid dysarthria. It is caused by injury or disease to the cranial or spinal nerves. It is a reflection of problems, sometimes in the nuclei, which then makes its way up to the final common pathway. Some characteristics are weakness, hypotonia, reduced reflexes, atrophy, fasciculations, fibrillations, progressive weakness with use, and some of the abnormalities with flaccid dysarthria are breathness, hoarseness, diplophonia, short phrase, reduced to max vowel duration, and a vocal flutter. And sometimes there can be a stridor and a weak cough. A good example of this is going to be from sample 1. My next dysarthria is going to be spastic dysarthria, which is caused by a bilateral damage to the direct and indirect activation pathways of the central nervous system. It manifests in the respiratory, phonatory, and resonatory and articulation. It takes place in the cerebral hemisphere. It is an upper motor neuron disease. Some of the major abnormalities include spasticity, weakness, reduced range of motion, and slowness of movement. Some of the characteristics include strained, harsh, and strangled grunts at the end of expiration. The strained sound is the most present with vowel prolongation. And to get a good example of this one, I really liked sample 9. One of the other dysarthrias to talk about is ataxic dysarthria. It is a motor speech disorder that has damage to the cerebral control circuit. It manifests in the phonatory, respiratory, resonatory, and articulation levels of speech, and it is most evident in speech and prosody. It is predominantly reflects the problem of motor control. It most clearly reflects the breakdown of timing and coordination, which is related to the control circuit. Clinical characteristics are unsteadiness during vowel prolongation, as well as mild alteration, loudness and pitch. Some of the diseases that could cause damage to the cerebellum and the cerebral control are an inflammatory disease, as well as cancer, degenerative vascular, and traumatic diseases. A good example that I liked for this one was found in sample 12. The next dysarthria that I am going to talk about is hypokinetic dysarthria. It is a distinct motor speech disorder that is associated with damage to the basal ganglia and part of the control circuit. It can manifest in any or all of the respiratory, resonatory, phonatory, and articulation levels, but it is often most evident in voice, articulation, and prosody. Some activities are often associated with the actions of the indirect activation pathway, and some of the characteristics of hypokinetic dysarthria are breathiness, a vocal flutter, rapid tremor, reduced maximum vowel prolongation, hoarseness, loudness, decay, basically reduced overall loudness. One of the disorders that is most commonly associated with hypokinetic dysarthria is Parkinson's disease, and a good example of this was found in sample 14. Now, the next one I'm going to be talking about is hyperkinetic dysarthria, which is different than hypo, and hypo means slower and hyper means faster. The motor speech disorder is associated with having abnormalities in the basal ganglia control circuit, and just like most of the other disorders, they can manifest in the phonatory, resonatory, respiratory, and articulation areas, but they most often have effects on rate and prosody. Hyperkinetic dysarthria interferes in the role or control circuits in each speech control. Like I said before, hyper, which means fast, it reflects the effects of involuntary movements on speech. And some of the clinical characteristics of hyperkinetic dysarthria are myoclonus, some tics, chorea, athetosis, dystonia, spasms, and tremors. A cause of the damage to the basal ganglia can occur from a degenerative disease, toxic metabolic conditions, infectious processes, vascular disorders, and trauma. Some of the phonatory abnormalities include an essential voice tremor, involuntary noises and vocalizations, voice interruptions, variable or excess loudness variations, and a slow tremor, which is also known as the myoclonus. Some of the other characteristics may also be breathiness and a harsh, strange voice quality. The example that I liked for this one was sample 18. And those were the dysarthrias. And then there is apraxia, which is different. Apraxia of speech is another motor speech disorder, and this one is distinguished with problems of control and execution. Apraxia of speech affects an individual's ability to translate conscious speech and plans into motor planning, which results in limited and difficult speech ability. It is a motor disorder caused by damage to the brain, specifically to the posterior parietal cortex or corpus callosum, in which the individual has difficulty then with their motor planning to perform tasks or movements when they are asked. Apraxia disorders begin at the top of the motor speech system under the cortical speech planning and programming. It is a neurological disorder that affects the brain pathways, and it's involved in planning the sequence of movements involved in producing speech. Some of the characteristics of apraxia are distorted substitutions, vowel prolongation, articulation errors, and distorted sound additions. A good example that I liked for apraxia is sample 30. And that is my information of the speech motor system. Thank you.